You can never change your life until you change something you do daily. Yes, the secret of your success lies in changing your daily routine and moving towards success. So in all your efforts towards success, your math facilitator Divya will be with you. And in this session, we are going to discuss chapter 4 of class 9, Lines and Angles. This is going to be a very interesting chapter, and this is an introductory video where I would explain you all the concepts, all the theorems, including the example problems, so that you'll understand and you can do your exercise problems comfortably. And also we'll do the exercise problems in the later video. So stay tuned, and now let's get started. So you have learned the basic concepts of geometry in your earlier classes. Yes, so let us just revise them very quickly. Now tell me, what is the point? A point is represented in this way. Yes, so a point is nothing but something which has no dimensions. Okay, a point has no dimensions. Clear? So this we have already learnt in the earlier chapter also, Euclid's geometry. Clear? So now this point has no dimensions, and how do you represent a point? You represent point using capital letters. Okay, so suppose this is point capital A. How do you read it? You read it as, this is a point capital A. Okay, so this is point A. Clear? Now what is line segment? Line segment is nothing but which has two end points. Okay, so this is a line segment. Clear? Now say you name it as PQ. Now PQ is a line segment, and how do you represent it? You represent PQ in this way, PQ with a line segment symbol above PQ. Clear? So this is nothing but line segment. Okay, it has two end points, it will stop here. Clear? Now what is a line? The same PQ, if I extend, okay, now this is P, this is Q, I am extending PQ on both the sides. Okay, so what is happening now? This is called a line. Okay, and you represent it as PQ with a line symbol over it. Clear? Now P and Q are points on the line, so you are representing in this way. Clear? And also line, you can represent it with small letters. Okay, small l, small m. You can represent line with using small letters, or you can represent line using the points on the line. Clear? Now P and Q are points on the line, so you can write PQ with a line symbol over it. Okay, this represents the line PQ. Okay, and also you can represent the same line using a small letter. Okay, if this is line PQ, you can represent PQ with small letters. Okay, L, M, N, and so on. Clear? So now line has no end. Okay, it can be extended in both the directions. Now here you can see it is extended in this direction. Okay, that is the reason you write an arrow mark, which means it is extended. Okay, and here also you see it is extended. Okay, so a line can be extended in both the directions, whereas a line segment is limited. Okay, it has two end points, that means it cannot be extended. Clear? Now let us talk about ray. Now what is a ray? A ray is nothing but it has one end point, or you can say it is a starting point, and from this starting point it goes on in one direction. Okay, one single direction. Clear? Now suppose this point is O, and let me take another point on this ray. Let it be A. Now OA is a ray. Now how do you represent it? So you write OA. Okay, since O and A are points on this ray, you write OA. And where is the starting point? It is on O. Okay, and it is extending towards A. So you will write the symbol in this way. Clear? Now the same thing if you write it in this way, AO. Yes, now this means that now the ray is starting at point A. Okay, so the starting point is A and it is extended. Okay, so this is A and it is extended towards O. Okay, in the direction of O. Clear? So always be careful when you are representing a ray. You have to see where is the ray starting, and from there you have to represent. Okay, so OA is this ray. Clear? And AO is this ray. Both are different. Clear? Because the direction is changing. Clear? So a ray can be extended in a single direction. Now can you tell me what are the examples of ray? Nothing but now you see you have your electric bulbs at home, or you have torchlight at home. Now when you switch on the torchlight, what happens? The light ray starts from this point and it goes on, right? So that is the example of ray. So it has a starting point and it just goes on in one direction. Clear? So these are the examples of rays, and be very careful when you are representing rays, because OA and AO both represent different, because here the starting point is O here and here it is A. Okay, so when you are representing a ray, be very careful. Clear? So this is a point, line segment, line and a ray. Okay, now what is an angle? Now angle can be formed with two line segments or two lines or two rays. Okay, now suppose if I take a ray OA, okay, and now if I move this ray, okay, in this direction. Okay, now suppose this is the final position of the ray. Okay, nothing but I have taken a ray in this way and I have moved it. Clear? So this is the final position. This is the initial position of the ray and this is the final position of the ray. Clear? So this was a ray and I am just moving it. Clear? How am I moving it? In this way. Okay, so this is the initial position and this is the final position. Now what is formed in between these two markers? It is nothing but an angle. Okay, similarly here also this is the initial position of the ray and I am just moving it. Okay, so this is the final position. So what is formed here? It is nothing but an angle. Okay, now how do you represent an angle? Suppose this is ray OB. Now this is the final position of this ray. Okay, so how do you represent it? This is nothing but angle. Now this angle is in between these 3 points A, O, B. Okay, nothing but it is between these two rays OA and OB. Okay, so we will use all these 3 points to represent the angle. Okay, so this is nothing but angle A, O, B. Just say it is angle A, O, B. Okay, angle A, O, B. So this angle you can represent as angle A, O, B. Just see my hand movement. It is A, O, B. That means you are representing the angle within this. Clear? So this is how you represent angle, and this also you have learned in your earlier classes. And we have learnt about different types of angles. What are they? Nothing but we have learnt about acute angle. What is it? Now suppose, now this is an acute angle. Yes, now if this is angle theta, now theta is nothing but it is between 0 and 90. Okay, so if theta is between 0 and 90, you call this as acute angle. Okay, so this is called acute angle. Why? Here you can see the angle is between 0, this is 0 degrees, and 90 is nothing but this one. Okay, so between 0 and 90, this angle is between 0 and 90. So this is called acute angle. Clear? So the condition is the angle should be between 0 and 90. Okay, now the next angle is right angle. Right angle is nothing but the angle should be 90 degrees exactly. Okay, so when theta is equal to 90 degrees, you call this as right angle. Clear? So this is called as right angle. Clear? So the next type of angle is obtuse angle. Okay, so now what is obtuse angle? So we have seen acute is nothing but an angle between 0 and 90. Right angle is an angle exactly 90 degrees. Now obtuse is nothing but an angle more than 90. Okay, so obtuse angle. Now suppose this is an obtuse angle. Okay, so suppose this is angle theta. Now this is called obtuse angle. Now this angle is more than 90 and it should be less than 180. So obtuse angle is always more than 90 and less than 180. Clear? Now let us talk about the other angle. Now what is this angle? Now this complete angle is called a straight angle. Okay, so this is called theta, it is called straight angle. Okay, so now here you can see if you measure this theta will be equal to 180 degrees. Okay, so this is called straight angle. Clear? So this is straight angle. Clear? Now there is another type of angle which is called reflex angle. Now we have seen if theta is 180, this is called straight angle. Now what if theta is more than 180? It is called a straight angle. Okay, so this is the initial ray. Now this ray is moving and it has come here. Okay, so this is the final position. Clear? Let me draw here. So this is the final position. Clear? So the ray has moved from here till here. Okay, now here you can see this angle is more than 180. Okay, so this is called reflex angle. Okay, so this is called as reflex angle. Clear? And now here the condition is this angle should be greater than 180 and less than 360. Okay, so any angle here between 180 and 360, it is called as reflex angle. Clear? So these are the different types of angles which we have learned in our earlier classes. Now let us talk about pair of angles. So this also you have learned in your earlier class. Now can you tell me what are the different pair of angles you have learned? Yes, do you remember? So the first type of pair of angle is complementary angle. Okay, so it is complementary angle. Now what is complementary angle? So now what is the meaning of pair? Pair is nothing but two. Anything in twos is called a pair. Yes, so here we'll take two angles together and we'll try to find out the relation between the two angles. Okay, so what is complementary angle? Any two angles, if the sum of any two angles is 90 degrees, okay, if the sum of any two angles is 90 degrees, then such angle is called as complementary angle. Okay, such pair of angles is called as complementary angles. Clear? So for example, if I have an angle in this way, okay, suppose if this is one angle which is 60 degrees, okay, and this is another angle which is 30 degrees. Okay, now these two angles are called as complementary angles. Why? Because you can see the sum of these two angles is how much? 60 plus 30 is 90. Okay, so these two angles form a complementary angle. Clear? Now tell me if one angle is given to you. Okay, suppose one angle is x degrees. Okay, so you have to find the other angle and these two angles are complementary angle. Okay, so you have to find the complementary angle of x. So how do you do it? So it is nothing but, suppose you take the angle which you don't know, okay, the unknown quantity, unknown angle as y. So how will you get y? It is nothing but 90 minus x. Clear? So from 90, if you subtract the given angle, you will get the unknown angle. Why? Because both the angles are complementary, which means sum of these two angles is 90. Okay, so if one angle is given to you, the other angle you can just subtract from 90, you will get the other angle. Clear? So which you have already learned in your class 7. Clear? Now the next type of angle is nothing but what? It is supplementary angle. Okay, so it is supplementary angle. Now recall what is supplementary angle and tell me. So supplementary angle is nothing but the angles whose sum is, it is 180. Okay, if the sum of two angles is 180 degrees, then such angle is called as supplementary angle. Okay, for example, here you have, say this is one angle, okay, say this is 130 degrees. Clear? And you have another angle, okay, say this is 50 degrees. Now what is the sum of these two angles? It's nothing but 130 plus 50, which is 180. Okay, so these two angles are called supplementary angles. Clear? So now if one angle is given to you in the similar way, then how do you find the other angle when these two angles are supplementary? How do you find it? It is nothing but, to find the angle, you will subtract the given angle from 180, because these two angles are supplementary, the sum is 180. Okay, so one angle you know, you don't know the other angle, you will just subtract this angle from 180 to get the other angle. Clear? Now what is the next type of angle which you have learned? Pair of angle. It is nothing but adjacent angle. Okay, so what is adjacent angle? What is the meaning of adjacent? Next to you, okay, side by side. Clear? So here also adjacent angles are nothing but now angles. Now let me take this example. Okay, these are two angles. Say this is angle 1 and angle 2. Clear? Now in these two angles you can see that there is a common vertex, so this is called vertex. Okay, so there is a common vertex for both the angles. You can see there is a common vertex, and you can see now this is a common arm. As you have learnt, this is called vertex of the angle and these are called arms of the angle. Yes, so this is a common arm. You can see this arm is common to both angle 1 and angle 2. Okay, so this is common arm. Clear? And what about the other two arms? Here you can see these two arms are called non-common arms. Okay, so this arm and this arm, these two are called as non-common arms. Clear? So in an adjacent angle you have a common vertex for both the angles and you have a common arm. Okay, and the next important point is there you have two non-common arms on either side of the common arm. Clear? So you have common vertex common arm, and non-common arms on either side of the common arm. Okay, now suppose this is the common arm. Now the non-common arms will be on the either side of the common arm. Okay, in this way. Okay, so this is one non-common arm, and here down this is another non-common arm. Clear? And this arm you can say it is common for both the angles. Clear? So such type of angles are called adjacent angles. Clear? So the condition is you should have one common vertex and one common arm. Okay, and what about the two non-common arms? They should be on either side of the common arm. Clear? Now moving on to the next type, you have linear pair of angles. Okay, so you have linear pair of angles. Now can you tell me what are linear pair of angles? Nothing but in linear pair of angles you have two conditions. The first condition is that the angles should be supplementary. Okay, that means the sum of the two angles should be how much? It should be 180. Okay, supplementary angles means the sum of two angles should be 180. And what is the other condition? The other condition is the angle should be adjacent. Clear? So linear pair of angles are nothing but the adjacent angles whose sum is 180 degrees, or you can also say it as linear pair of angles are adjacent angles which are supplementary. Clear? So now here you can see these two angles form supplementary angles as we have discussed, but these two angles are not adjacent angles. Okay, these two angles are supplementary angles, but they are not adjacent because they do not have a common vertex. They are different and there is no common arm. So these are supplementary but not adjacent. Clear? Now these are adjacent angles. Clear? But they are not supplementary because you see angle 1 plus angle 2 is not 180. Yes, because 180 is what? It is a straight angle. Here you cannot see it is a straight angle. Okay, now let us write what is linear pair of angle. Let us take this. Now suppose this is a straight line and you have something like this. Okay, now this is one angle and this is the second angle. Now just see angle 1 plus angle 2 is how much? It is nothing but 180 because this is a straight line. Okay, and this is a straight angle. This complete thing is what? It is straight angle. We have learned straight angle is nothing but 180 degrees. Yes, so this complete thing angle 1 plus angle 2 is 180. Okay, and what about the two lines, two angles? How are they? They are adjacent to each other. Why? Because you have a common vertex and this is a common arm, and the two non-common arms are lying on either side of the common arm. Clear? So this is adjacent as well as supplementary. So this type of angles are called as linear pair of angles. Clear now? So what is the next type? Next type of angles you have learnt is vertically opposite angles. Okay, so now what are vertically opposite angles? Now when two lines meet each other, okay, so suppose two lines are meeting each other in this way, you have a point of intersection in this way. Okay, so two lines are meeting and there is a point of intersection. Okay, they are meeting at a point, say this is point O. Okay, now you can see four angles are formed here. This is one angle, okay, this is 2, this is 3, and this is 4 angles are formed. Okay, now what is vertical? Vertex. Vertex is nothing but this point where the two lines are meeting is called as vertex. Clear? We'll go by the name. Vertex is the point where the two lines are meeting. It is called vertex. Okay, and what is opposite? Opposite. Yes, so vertically opposite means the angles which are opposite to each other. And how are they opposite to each other? They are vertically opposite. Okay, that means they are on either side of this vertex. Clear? So now you can see, now let me redraw it. Okay, suppose these are the two lines. Okay, now this is one angle. Now this is the vertex firstly. Oh, this is one angle. Now if I want a angle vertically opposite to this angle, that means I want angle on other side of vertex. So it will be this one. Okay, now these two angles, now this was angle 1 and this was angle 3. Now angle 1 and angle 3 are vertically opposite angles. Clear? Now similarly if you take the other two angles, now these are the lines which are intersecting, okay, at point O. Yes, now here this is one angle. So what is the other angle opposite to this angle? over the vertex. This is the vertex. So opposite to vertex you want one angle, so this will be the angle. Yes, so this is angle 4, angle 2 as we have named here. Okay, so angle 2 and 4 is one pair of vertically opposite angle, and angle 1 and 3 is another pair of vertically opposite angles. Clear? So when two lines are meeting each other, how many pair of vertically opposite angles did they form? You can form two pairs of vertically opposite angles. Clear now? So just go by the name. Vertically opposite is the angles are opposite through the vertex. Okay, so they are on either side of the vertex. They are called vertically opposite angles. Okay, and you have also proved in class 7 that vertically opposite angles are equal. Okay, which means now here you see angle 1 and angle 3 are vertically opposite, so you can write angle 1 equal to angle 3. Okay, because they are equal, you have proved it. Now angle 2 and angle 4 are vertically opposite, so you can write angle 2 is equal to angle 4. Clear? Now how did we prove this? It's very simple. Okay, so suppose, let me take these two markers to explain you. Okay, now if these are the two lines, clear? Now see, these are the two lines intersecting at this point O. Okay, now this is angle 1 and here down this is angle 3. Clear? Angle 1, angle 3. Okay, now what you will do is just rotate this. Okay, do you draw two lines on your paper, take two pens or two sticks, okay, and mark something here at the top end so that you can represent what is angle 1. Okay, so here at the top end, now here you can see clearly you have marker caps, so here at the top this is angle 1. Okay, now when you completely rotate this without changing this, okay, without moving this, okay, without disturbing them, so you can see angle 1 is equal to angle 3. Clear? Do this and you will find angle 1 equal to angle 3. Clear? So by that we are writing vertically opposite angles are equal. Now let us discuss about the different types of lines. Okay, and you have learned about parallel lines. What are parallel lines? Now suppose if you have two lines in this way, okay, so this is one line and this is the second line. If you have two lines in this way and the distance between these two lines is always same. Okay, so the distance between these two lines is always same. Okay, so then when you extend these two lines in any direction, either in this direction or this direction, they do not meet. Okay, so the first point is distance between the two lines is always same, and if you extend the lines they never meet. Okay, so they do not meet. So these type of lines are called as parallel lines. Can you give me some examples? Very simple example which you see in your daily life is your notebook. You have a ruled book, yes. So how are the lines in your book? They are in this way. Yes, so these are called parallel lines. The distance between these two lines will never change. Are they changing? No, so they never change, and these two lines they do not meet. Even if you extend them, they do not meet. Okay, so these are called parallel lines. Okay, so now next is intersecting lines. So what are intersecting lines? If two lines are in this way, okay, suppose if this is one line and you have another line, now these two lines are meeting at a point. Okay, so they are meeting at a point. So this type of lines are called intersecting lines. Okay, when two lines meet at a point, these lines are called intersecting lines, and this point is called point of intersection. Okay, so this is called point of intersection. Clear? So it is point of intersection, and these lines are called as intersecting lines. Okay, now what about concurrent lines? Now it is similar to intersecting lines, but here we take two or more lines. Okay, suppose you have number of lines meeting, okay, so in this way. Clear? Now all these lines are meeting at a point. Okay, so let this be point O. Okay, so when two or more lines meet at a point, then these lines are called concurrent lines. Okay, and this point is called as point of concurrence. Okay, so it is called as point of concurrence. Clear? So now this is the difference between intersecting and concurrent lines. In intersecting you have only two lines. Okay, in concurrent lines you have two or more lines intersecting at a single point. Clear? So and parallel lines, they never meet, they never intersect. Clear? Now that we have revised all the basics, now let us move on to the new concept of class 9. Okay, so let us talk about linear pair of angles axiom. Now what is axiom? we have discussed axiom is nothing but it is a truth. Yes, it is self-evident truth. Clear? So you don't have to prove it. Clear? The axioms are statements which are self-evident. That means by just looking at it, by just observing it, you will know that they are true. Okay, this is what we have learned in Euclid's geometry. Yes. So now let us state linear pair of angles axiom. Okay, so what is it? Now we have learned what are linear pair of angles. Linear pair of angles are nothing but the angles whose sum is 180 and they should be adjacent. Okay, so now the statement for this linear pair of angles axiom is, suppose you have a straight line. Okay, suppose this is a straight line. Okay, and now you are drawing a ray on this straight line. Okay, so there is a straight line and this ray is standing on the straight line. Okay, suppose if I take this line as AB. Okay, now this ray OA is standing on the straight line. Let it be OC. Okay, OC is standing on the straight line. Okay, so now the angle so formed, this is angle 1, this is angle 2. Okay, now these angles, the sum of these angles is 180 degrees. Clear? So when a ray stands on a straight line, okay, so this is a straight line. When a ray is standing on a straight line, okay, so then the sum of the angles formed is supplementary. Okay, that means it is 180 degrees. Clear? So if a ray stands on a straight line, the angles so formed are supplementary. Okay, so by just looking at it or using your protractor also you can see a straight line. This straight line angle is how much? 180. Okay, so angle 1 plus angle 2 is how much? 180 degrees. Okay, so this is nothing but linear pair of angles axiom. Okay, now let us try to see the converse of linear pair of angles axiom. Converse is nothing but the reverse of it. Okay, here you have seen you are taking a straight line and you are making a ray to stand on the straight line. Okay, you are marking a ray on the straight line. Okay, so the angles so formed is 180. But now let us take in this way. So this is something you have, okay, and you have a ray on this. Okay, now this is angle 1, this is angle 2. Okay, now angle 1 plus angle 2 is 180 degrees. Clear? The sum of these two angles is how much it is? 180 degrees. Then these are called non-common arms. Yes, now here you can see these are adjacent angles. Angle 1 and angle 2 are adjacent angles and this is the common arm. Yes, and these two are non-common arms as we have learned. Okay, so these non-common arms, they form a straight line. You can see these non-common arms, they are forming what? They form a straight line. Okay, so this becomes a straight line when the sum of these two angles is 180. Clear? So earlier we learned that if this is a straight line, okay, and if you are having a ray on the straight line, then the sum of these two angles formed is 180. Okay, now you are learning that suppose you have something like this. Okay, you have a ray, you have two angles. Okay, and if the sum of these two angles is 180, then the non-common arms, they form a straight line. Clear? So this is linear pair of axiom, linear pair of angles axiom, and this is the converse of it. Clear? So these we use in solving our problems. Okay, now moving on to the next concept, let us see what is the angle at a point on a straight line. Okay, suppose you have a straight line in this way. Okay, and there are some angles formed with the straight line. Okay, so this is angle 1, angle 2, angle 3. Okay, now all these angles are formed at a single point O. Okay, so you have a straight line and you have a point O on the straight line, and all these are angles formed on this straight line at this point on the straight line. Okay, now what is the sum of all these angles? As you know, this is a straight angle. Okay, so angle 1 plus angle 2 plus angle 3 is what? It is 180 degrees. Okay, so angles at a point on a straight line is nothing but, now this is a straight line and this is a point on the straight line, and if you want to find out what is the sum of the angles at this point, Okay, at this point you have how many angles formed? 1, 2, 3 angles formed. So the sum of these angles at this point is nothing but 180, because you can see you form a straight angle when you add up all these things. Clear? Because this is a straight line. Okay, now angles at a point. Now suppose this is a point O. Now I want the angles which are formed at this point. Now how will you do it? Suppose you have a line in this way, okay, and this is the point O, okay, and you have some angles in this way. Okay, now all these are angles, angle 1, angle 2, angle 3, angle 4, angle 5. Now all these are angles around which point? Around a single point O. Okay, so this is single point O. Around the single point O you have 5 angles. Okay, so what is the sum of all these angles? Now as you have learned, angle 1 plus angle 2 plus angle 3, this top angle sum is 180. Okay, similarly you can see the bottom angle, this is also 180. Okay, so this top angle is 180, this here, this down is also 180. Now what is this complete angle? It is nothing but 360 degrees. Okay, so angle at a point, if you take the sum of all the angles at a point, it is 360 degrees. Clear? Now if you take the sum of angles of a point on a straight line, it is nothing but 180 degrees. Clear? Now let us learn a theorem. Okay, so if two lines intersect each other, then the pairs of vertically opposite angles thus formed are equal. Okay, so two lines are intersecting each other. Okay, suppose if I have two lines in this way, so say this is line A, B, okay, and I have another line, say C, D. Okay, so these are the two lines and they intersect each other at a point O. Okay, so when two lines are intersecting at a point O, we have learned that you have 4 angles formed in this way. Okay, and what are these angles? They are vertically opposite angles. Yes, so if two lines intersect each other, then the pair of vertically opposite angles thus formed are equal. So you have to prove that the vertically opposite angles which are forming here are equal. Okay, so you have already proved it using some activity, but here let us prove it using some steps. Okay, so you have already learned linear pair of angles axiom, so using that we will prove this. Okay, so now see, now we have taken given. So what is the given statement? There are two lines. Okay, so AB and CD are two lines which intersect. These two lines intersect at a point O. So they intersect at point O. Okay, so what is happening when they are intersecting? Vertically opposite angles are forming. Okay, so you have to prove that. To prove, what should you prove? You have to prove that the pair of vertically opposite angles are equal. Okay, that means this angle should be equal to this angle. Okay, so let us write here angle AOD. This angle is nothing but angle AOD. Clear? So angle AOD is equal to angle COB. You have to prove angle AOD. That means this angle is equal to angle COB or BOC. Both are same. Okay, COB or BOC both represent the same angle. Clear? So angle AOD equal to angle BOC. Clear? So this is what you have to prove. And also you have another pair of vertically opposite angles. Yes, left and right. You have AOC. Okay, you have to prove angle AOC is equal to angle BOD. Okay, so angle AOC equal to BOD. This is what you have to prove. Okay, so two pairs of vertically opposite angles are formed. One is up and down and one is left and right. Okay, so you have to prove that the angles are vertically opposite angles are equal. Clear? So that is what we have written. Now how do you prove it? Okay, so proof. Let us write the proof. Clear? Now you know that CD is a straight line. Okay, since you have taken two lines intersect, so this is a line, it is a straight line, right? So CD, now the CD is a straight line. Okay, so for your easy understanding I am just trying to simplify the figure. Okay, so CD is a straight line. Clear? Now on this CD you can see there is a ray OA. Okay, so on CD you have a ray OA. Okay, so this is OA. Clear? Now just look here, CD is a straight line. Okay, so on CD what do you have? You have ray OA. Okay, now you have learned using linear pair of axiom that these two angles are how much? The sum of these two angles is 180. Okay, if a ray stands on a straight line, the angles so formed, the sum of angles so formed is 180. Okay, using linear pair of axiom. Okay, so now linear pair of angles axiom. Okay, so now just let us write it here. Now angle, so what are these two angles? We are talking about these two angles. Angle COA, angle COA or angle AOC, both are same, plus angle AOD. Okay, AOD is how much? It is 180 degrees. Why? Since you have understood here using linear pair of angles axiom. Okay, so I am writing it as LPA, linear pair of angles axiom. Clear? But in your exam, in your notes, you have to elaborate it. Clear? So you will write since. These three dots symbolizes since. Okay, since using linear pair of axiom you are writing the step. Okay, so in geometry always reasoning is very important. Don't forget that. Okay, so it is the habit of a good math student. Clear? So now let us take this. So now you see AB is a line again. Okay, so let me draw here. So this is AB. AB is a line. Okay, now on AB you can see OC is a ray. Okay, so on AB you have OC in this way. Okay, so this is OC. Clear? So just for simplifying I am drawing it in this way. Okay, so AB is a line. Clear? And OC is a ray. Now what about these two angles? Sum of these two angles is also 180. Yes. So now let us write here. Now this is angle AOC. This angle is nothing but AOC. So angle AOC plus, now what is this angle? It is nothing but BOC. Angle BOC is equal to 180 using what? Using linear pair of angles axiom. Okay, now both the 180. Okay, this is equal to 180 and this also equals to 180. So let us equate these two. So angle AOC plus angle AOD is equal to angle AOC plus angle BOC. Okay, so here you can see AOC is common. Okay, so from this you can write angle AOD is equal to angle BOC. Okay, so what is angle AOD? This one, angle AOD is equal to angle BOC. Okay, so you have proved that these two angles are equal. Okay, so this is proved. Clear? So similarly you can also prove the next one. How? So here you have considered this CD as a line, OA as a ray. Okay, next you have considered AB as a line and OC as a ray. Okay, so nothing but what did I do here? So I have taken these two angles first, then I have taken these two angles. Let me write it here. So I have taken these two angles first. Yes, then I have taken these two angles. Okay, now you can see this is common, so eliminating this, equating this, you are eliminating this angle. Okay, so you got these two angles. So now what do you want? You want these two angles. You have to prove that AOC is equal to BOD. So what do you take? Now you will take line AB. Okay, you want this angle. So you will take line AB and you will take these two angles. Okay, so that means you will take line AB with OC standing on it. Okay, so AOC plus COB is 180. Okay, now what you will do is you will consider CD line. Okay, and you will take OB ray. Okay, so that means you will take these two angles into consideration. Okay, then angle BOC plus BOD is how much? 180. Okay, now equating both the things, like here you see this is common. Okay, so this you can eliminate, so you will get these two angles are equal. Okay, so I want you to do it by yourself. I have explained it. Now just write down in a notebook these steps. Okay, so after this, now to prove this you will follow those steps. Clear? So this is nothing but you have proved that when two lines intersect each other, then the pair of vertically opposite angles formed are equal. Clear? So we will use these linear pair of angles axiom and this theorem in our next problems. So using all the concepts which we have learned till now, let us solve this problem. Okay, so in this figure you can see you have three angles formed and AB is a straight line. Okay, so you have to find the value of x, also you have to find the value of these angles. Clear? So you can see now all these angles are at a point. Okay, so if you consider this point as O, all these angles are at this point O, and O is on the straight line. Okay, so that means using our concept, the sum of these angles at a point on a straight line is how much? It is 180. Okay, we have learnt it. So adding all these angles, you will get 180. Okay, so let us write here. So we know that sum of angles at a point on a straight line. Okay, so at a point on a straight line is how much? It is 180. Okay, on a straight line is 180. Okay, so nothing but you will add all the given angles. Okay, so it is 3x plus 7. Okay, so plus 2x minus 19 plus x is how much? It is 180 degrees. Clear? So just solving it. So 3x plus 7 plus 2x minus 19 plus x is 180. Okay, so you have 3x plus 2x is 5x plus x is 6x. So 6x plus you have 7 minus 19 is nothing but minus 12. So 7 minus 12 equal to 180 degree. Okay, so you want the value of x. So let me take 12 to the other side. So it is 180 plus 12. Okay, so this is 192. Okay, so 6x is 192. So what is x? X is 192 divided by 6. Okay, so 6 ones are 6, 6 3s are 18. You have 1 as a reminder. Now this is 12. So 6 2s are 12. Okay, so x you have got it as 32. So x is 32 degrees. Okay, so now you want the angles also. Okay, so this is angle AOC. So angle AOC is nothing but how much? AOC is 3x plus 7. Okay, so now next angle COD. This angle COD. Angle COD is what? It is 2x minus 19. Clear? Now the next angle is angle BOD. This angle. Angle BOD is nothing but x. Okay, so just substitute the value of x here. So it is 3 into x is 32 plus 7. Okay, so it is 3 2s are 6. This is 96 plus 7, which is nothing but 103 degrees. Okay, so this is 2 into, now x is 32 minus 19. Okay, so this is nothing but 64 minus 19, 45 degrees. Okay, so now x is nothing but how much? X is 32. Okay, so these are the answers you got: 103, 45 and 32. And you know that sum of all these angles should be how much? 180. So let us cross check now. So 103 plus 45 plus 32 should be how much? These three angles, if you add, the sum should be how much? It should be 180. So let us see. 5 plus 3 is 8. 8 plus 2 is 10. Okay, so this is 5 and 8 and this is 180. Okay, so that means the answers which you got are correct. Now moving on to the next question. You have two lines PQ and RS intersecting each other at a point O. Okay, and it is given that angle POR is to angle ROQ is 5:7. Okay, so you have to find all the angles. Clear? So now angle POR, that means angle POR, this angle. Okay, and angle ROQ, that means this angle. Okay, so these two angles we are talking about, this and this. Okay, so these two angles are in the ratio 5:7. Okay, and again by seeing this, by looking at this, we have just proved in the theorem. How? We have just learned the theorem to prove that vertically opposite angles are equal. How did we do that? We have taken this as a line. Okay, and this OR is a ray standing on this line. So using linear pair of axiom, angles axiom, you can see that the sum of these two angles is how much? 180. Okay, so angle POR plus angle ROQ, that means POR plus ROQ, this entire angle is how much? 180 degrees using linear pair of angles axiom. Okay, but there is another condition that angle POR is to angle ROQ is 5:7. Okay, so you can take angle POR as 5x, angle ROQ as 7x. Okay, so this is nothing but 180. Okay, now 5x plus 7x is 12x is 180. So what is the value of x? X is 180 divided by 12. Okay, so this is nothing but 6 2s are 6 3s are 18, 0 2 1s are 2, 15s are 30. So x is 15. So you got the value of x as 15. Okay, so substitute this value here. So what is angle POR? Angle POR, you have taken it as 5x. Okay, so it is 5 into 15. Okay, now angle ROQ, you have taken it as how much? 7x, because the ratio is 5:7, it is given. Okay, so 7x, so it is 7 into 15. Okay, so the answer is 5 5s are 25 and this is 7. Okay, so this is 75 and here it is 35, so this is 105. Okay, so POR is 75. POR, this is 75. Okay, so this angle is 75. Okay, now angle ROQ, this angle is how much? It is 105. Okay, now can you tell me what are these two angles? By using vertically opposite angles theorem, you can see angle, let me write it here, angle POS is equal to, the top angle is equal to bottom angle, angle ROQ. Using what? Using, because they are vertically opposite angles. Okay, so ROQ you already got it 105. So what is angle POS? POS is nothing but 105 degrees. Okay, now what is this angle? Now these two angles are also vertically opposite, left and right. Okay, so angle POR is equal to angle SOQ. Okay, QOS or SOQ both are same. Okay, but angle POR you got it as 75. Okay, so what is angle SOQ? It is also 75 degrees. Why? Because vertically opposite angles are equal. Okay, so this is 75, this is also 75, this is 105, this is also 105. Okay, so in this way you got all the 4 angles. Okay, so whatever concepts you have learned till now, all those concepts you are going to use in the problems. Okay, so firstly, whenever a problem is given to you, you will understand the question. Okay, and you will observe the given figure. Okay, and you will try to use all the concepts which you have learned, you will try to apply them here. Clear? So only very basic steps. By just looking at the figure, looking at the question, you may think that it is very complicated, but no, these are very easy. Only thing you have to do is you should have a complete understanding about the concepts. Okay, then you will read the question carefully, understand the given figure, understand the question. Okay, and then you will try whatever concepts you have learned, you will try to apply them here. You will easily get the answer. Clear? I hope you have understood all the concepts. Now it's your time to try it yourself, so do it yourself. Now AB and CD are two lines that are intersecting at point O, and you have also array OE. Okay, so here you see some angles are formed. Okay, so in the question it is given that angle AOC, okay, this angle plus angle BOE. Okay, that means this angle plus this angle is how much? It is 70 degrees. Okay, and angle BOD, this angle is 40 degrees. You have to find angle BOE. Okay, this angle you have to find. Okay, and also you have to find reflex of angle COE. COE is this angle. Okay, this one. You have to find the reflex of it. That means you see angle COE is this. This is COE. Okay, so firstly you will find this angle. Reflex of angle COE is nothing but this one. Okay, so you know that this complete angle is 360. You will get some answer here. Say you will get an answer x here. So you will subtract this from 360. So you will get this angle. Okay, so this is reflex of COE. Clear? So let me also give you one more clue. Now angle AOC plus angle BOE. These two angles sum is how much? It is 70. Okay, but you can see here AB and CD are how they are. Now you see in this way AB and CD are two lines intersecting, and you can see here this is nothing but D and this is 40. Okay, so how are these two angles? They are vertically opposite. Okay, so from this you can say D is 40 degrees, because vertically opposite angles are equal. So this is 40, which means this is also 40. Okay, now you got the condition that AOC plus BOE is 70. So out of these two you got one as 40. AOC is 40. Now what is BOE? You can simply find it out. 40 plus BOE is 70, so you can find what is BOE. Okay, so now using BOE, this angle and D. Okay, so this is 40. Here you will get some answer from here. Okay, and you don't know what is this angle, you will take it as X. Okay, but you can see that all these angles, sum of all these angles is how much? 180. Okay, so you will add all the three angles, so you will get the value of X. Okay, so once you get the value of X, you want what? You want reflex of COE. That means you want this angle, not this one. Okay, so you will subtract this angle from 360, so you will get the reflex of COE. Clear? So do it yourself. Now it's time to practice with me. So I want all of you to quickly revise all the concepts. Okay, so now be alert. Okay, so apart from all the earlier concepts which you have learned in your earlier classes, so we have learned some new concepts today. What are they? So you have learned linear pair of angles axiom, which is very important. What is it? If a straight line, if a ray stands on a straight line, then sum of the two angles so formed is what? It is 180 degrees. Okay, now what is the converse of it? If two angles formed, if the sum of two angles is 180, then the non-common arms forms what? They form a straight line. Okay, so next is angles at a point on a line. On a line, if you have a point, now angles at a point on this line is how much? It is 180. Okay, now angles at a point, at this complete point, the angles, the sum of the angles is how much? 360 total angle. Okay, now you have also learned a theorem, vertically opposite angles are equal. Okay, if two lines intersect each other, at the point of intersection you have two pairs of vertically opposite angles and the vertically opposite angles are equal. Clear? So practice them, and also don't forget to mention your answer of do it yourself in the comment section below. So I hope you enjoyed learning with me in this session. I'll meet you with the next part of this chapter in the next session. So stay tuned to Math Facilitator, and also let me know in the comment section how did you like this video. Comment and tell me which part did you like, or is it easy or not, because the entire class 9 you're going to deal mostly with geometry. So how are you liking it? Let me know with your comments, and also don't forget to subscribe to the channel, like this video right now and subscribe to the channel right now, and I'll meet you with part 2 of this chapter very soon. Thanks for watching.